In this example, we're being asked to integrate 4x minus 1 divided by the square root of 1 minus x squared. So the first thing we have to do is decide, what method would be appropriate here. One thing that catches my eye right off the bat is this radical here, and if this was a Calc 1 type of integral, we would definitely expect this to possibly be like a u substitution integral, right? Because of the composition, because of the layers, where the u would be 1 minus x squared, and maybe that's the route we're going to go. We're not really sure yet. If u was 1 minus x squared, then the du would be minus 2x. One thing that catches my eye is I've got a 4x, and so that seems close enough that we can make that work. Minus 2x and 4x only differ by a constant. However, one thing that kind of messes that up a little bit for us is this guy, this minus 1. That really has nothing to do with the du or du or whatnot, and it would really kind of mess up that u substitution idea. Another thing that catches my eye is this roughly looks like an arc sine integral, because in the denominator I've got the square root of a squared minus u squared, where the u is x squared. Where the u is x, and the du would be 1, or the derivative of u would be 1, which seems pretty decent for this guy, but the 4x has really nothing to do with that. So what do we do? That's two good ideas. None of them, neither one of them seem that perfect. Is it u substitution, or is it an arc sine type of integral? Well, it turns out with examples like this, it's very possible that it could be both, but you have to set it up correctly. If you look here, I'll circle this. This part right here looks like a very nice u substitution integral, and this part right here seems like a very nice arc sine type of integral. And so they're separated by subtraction. So this is a very common thing. That's why I chose this example, just to make you aware of these types of examples. We can separate this into two integrals. The first one would be 4x divided by the square root of 1 minus x squared, and then minus, and we'll separate this into a second integral of 1 over the square root of 1 minus x squared dx, like this, where this guy will be a clear-cut u substitution integral, and this guy here will be a clear-cut arc sine type of integral. All right, you could probably finish out those algebra steps yourself, but I'll do it with you. For u substitution, the u would be 1 minus x squared, the inside of the layers, and the du would be negative 2x dx. So I need to do a little work here. First of all, I'll pull the 4 out because I don't really need the 4, and then I'll put a negative 2 on the inside with a negative 1/2 on the outside to keep everything balanced. So I'm sorry that's a little messy there, but hopefully you can follow that there. Okay, and then for this guy here, the a would be 1 because you have 1 squared, and the u would be x because you have a squared minus u squared. So this seems to fit pretty well also. So this one's practically ready to go. All right, so let's see here. What will we have? I'll tell you what, just so I can keep everything on the same page, just so I don't have to copy this again. We'll have this term here. Okay, we'll have this term here. This will be negative, a half times 4 is negative 2, and then you have the integral of, let's see, what will this be? Negative 2x dx would be du divided by the square root of u, right? Because 1 minus x squared was our chosen u. Okay. This is a simple power rule integral. Right, and then minus, and if you're okay with this guy's ready to go ahead and integrate. I can just go ahead and do his integral right now. This would be, if you look back at your arc sine rules, so we'd have minus arc sine of u over a, in this case x over 1, and then with a plus c. So I still have to compute this integral. I'm not done quite yet, so I'm going to have to turn to the next card. But I've done the second integral. Now I just have to do the first one. All right. I think I will rewrite the. I'll rewrite the first integral just to make it look a little better. We have -2, the integral of u to the minus 1/2 du, and then minus, then this integral that was already computed, arc sine of x, all right, with a plus c on the end. Okay, rewriting this helps me see this more clearly as the power rule. So I'm going to add 1 to this exponent to be u to the positive 1/2 with a 2 over 1 out front. That's the same thing as dividing by a half. U to the 1/2 divided by 1/2 or times 2. But you already have a -2, so 2 times -2 is -4. And then minus, we still have the arc sine of x, that guy's finished, plus c. And the only thing that we need to tidy up a little bit is this integral should be in terms of x at the end of the day, not u or anything like that. So what was x? What was our chosen, what was u rather? U was chosen to be 1 minus x squared, 1 minus x squared. All right, so I'll have as a final answer, -4. The 1/2 power is the same as a square root of 1 minus x squared, that's what u was, minus arc sine of x. And I don't need an additional plus c for this integral. One constant of integration, if you call it c, and another constant of integration, if you absorb those together, it's just a new constant. So we can keep this notation plus c. So this is the indefinite integral for this integral here. And the reason I chose this example is this is a very common thing to do. You'll have a particular integral that looks like it could be different things, and in fact you have to break it apart, and each individual piece might be a different technique. U substitution, an arc sine, an arctan integral, or whatever the case may be. But you very often have to break these apart into smaller pieces.